Great to see everybody here. See a lot of familiar names from the past, which is awesome. My name is Braxton Landseal, and I manage our developer adoption team, which includes everything from our technical support. So you find us in Discord and on the forums, helping you get unblocked. Our partner engineering team, which is working with our larger strategic partners, building sample code on our GitHub, things of that nature. And then our technical documentation team, so all of the guides, API reference, tutorials, feature pages, all that information is part of the documentation team. Yeah, and for that, I've been at Niantic for about 2.5 years. The first year and a half, I was on the partner engineering team myself, so I got to do a lot of these. I don't get to do as many of these anymore, so this is kind of a treat for me, and I see some familiar faces, which is always fun. So happy to be here. Perfect. I'll leave it in this mode because we got all my handy links here. And there should be, sounds like Pablo provided some resources ahead of time. So all those links should be available to you as well. So just have those handy to click through. And one note here, with about 35 minutes to do this, unfortunately for the Unity side, about half of the time is just going to be setting up, getting things going in Unity. And after that, we'll dive into the actual location-based part. So if not everybody is able to get through the whole thing because we got to move kind of fast, just a reminder that there will be a recording, and sorry in advance, but we'll do our best. Perfect. So we are here to talk about building a location-based experience using Lightship ARDK. Just a reminder, if you're here, the Lightship ARDK is a Unity-based development kit meant for your mobile applications. Prerequisites to make sure, hopefully you already have these installed, and we'll walk through a couple pieces of them, like the Lightship developer account, but you will need Unity version, I won't read the whole thing off there, but 2021 LTS or 2022 LTS, a Lightship developer account, which I'll show you how to do, Visual Studio Code or any development environment that you prefer. And then for Apple specific things, if you're going to build the iOS, you'll need Xcode, you'll need an Apple developer account. And then of course you need a computer and a mobile device to actually build and test things with. So creating location-based experience, we'll show you how to use the geospatial browser that we talked about earlier. Use that to find AR locations, these VPS locations, and get the mesh of those locations. We'll show you how to remotely author your digital content to these AR VPS locations. Show you how to use the ARDK sample scenes, which we'll talk more about soon. Show you how to use AR session playback recordings to test AR features in the Unity editor. And if some of those terms are mouthful, we'll talk more about it here soon, and it'll all make sense, I hope. So the very first thing we need to do is we need to create a Lightship API key. This is so we know who you are. It's a common practice for using dev kits or using services from platforms. So to do that, we'll actually go to lightship.dev. And you'll create a project. So if you hopefully you have an account and you can log in, and you go to the projects tab. I have a whole bunch of projects, so I can I'll select one of them, just a test project. And once you create a project, there'll be an API key field here, and you can just copy that. So we will come back to that here in a little bit. Once you've created an API key, we are actually going to head to GitHub to get our sample projects repository. So hopefully you have that link handy as well. If not, it is GitHub/Niantic-Lightship/ARDK samples. And once you're there, we're going to go ahead and download the code there. So you can do that by heading to the samples, and then code, and just downloading as a zip. And I will do that. I have several versions of these now as I've been ensuring this, practicing for this workshop. So we'll show where that's at. And then I believe I have a workshop folder. So I'm just going to save that somewhere that I can find it here in a little bit and unzip it. Great. So we've got an API key, we've got our sample project. These samples are meant to show off a variety of different features in very small, simple Unity scenes. So we have everything from VPS to meshing, depth, semantics, a lot of really simple scenes just to kind of kickstart you, show you what's supposed to be happening and how they're supposed to work. And they can also be a jumping off point if you're going to build your own thing, but you kind of want to use some boilerplate code or a template to get rolling. Okay, so we've got our Lightship sample project. We've put it somewhere safe. We've unzipped it in that folder. So now we're going to open that in Unity. So I'm going to go to the Unity hub here. I'm going to add a project. And we're going to go find where you saved it. And we're going to open that project. It'll add to our Unity hub. This will take a minute. While we're sitting here waiting, we're updating these scenes all the time. Every new version, with every new feature that comes out, we generally try to have a sample scene as part of this package that also demonstrates how to use the feature, has code snippets, and allows you to easily get going and jump off on your own project with it. For the VPS one, we'll be using a scene that serves as like a starting point for actually authoring content to a specific location. So we'll get there in just a moment as the Unity package manager has a hard think. And while we're waiting, just to kind of talk about what the steps ahead are, as this is opening, what we're going to do is we're actually going to open one of these sample scenes. And from there, we're going to go to our geospatial browser, find a real location, pull that location into our project, curate some content for the location, and then we're actually going to simulate using VPS all in the Unity editor. This is powerful, especially because for a feature like VPS, we don't want to constantly have to get in the car and drive somewhere to test it or get up and walk all the time. So this is going to provide a really handy way to constantly test, iterate, keep that development cycle nice and fast. All right, we're almost there. The development iteration is faster than the project opening, I promise. Okay, so now we have Unity open here, which is great. You should be able to open the project. You should be able to see under assets, we have samples, and under samples, we should have things like persistent AR, and we'll get into these in just a moment. So back to steps here. So now that we've opened the project in Unity, we need to enter that API key we had. So either go back and grab it, or if you still have it copied, great. And we are going to do that by going up here to the Lightship tab, drop down and select settings. And you'll see this right here, and you can paste your API key right here. I will do it off camera since it is my API key, paste it, and then we're good. So now the project has an API key that allows you to work with all of Lightship's services. So now that our project is open in Unity with an API key in it, We're going to open the remote authoring scene, which is under assets, samples, persistent AR folder, scenes, remote authoring.unity. So that's assets, samples, persistent AR, scenes, and remote authoring. Great. So once you open that scene, you should see some placeholder text here. You should see some game objects here in the hierarchy, just like this. And this will allow us to hit the ground running while building our location-based experience. All right, moving on there. The last thing to really have Lightship set up for success is configuring Lightship. So at the top menu again, that Lightship menu, we're going to go to XR plugin management and make sure that we're selecting Lightship as the plugin provider for our platforms. So we'll go to Lightship, XR plugin management. That will bring up this window here, and we're going to make sure this is checked for the platforms that we're working with. So I'm going to be working with iOS, so I want to make sure that it is selected for iOS. Great. Awesome. And I know we're flying through this. This is kind of a checkpoint to make sure we have our Unity project set up, because at this point, well, with Lightship in it, so now we're ready to actually build something with Lightship. We're ready to use some of the Lightship services and go from there to actually curate our location-based experience. Maybe some reactions in the chat if we can get some thumbs up, thumbs down. A reminder, it's being recorded, so if we get thumbs down, we have a great developer support team to answer questions, but I think we'll have to keep things moving just in the interest of time to make sure we get through the whole walkthrough here. I see a couple thumbs up, which is great. Ricky with the plethora of thumbs ups, thank you. Awesome, we will keep moving right along and then just to make sure we get through everything. So now that we have Unity set up, we're going to move on and talk about the geospatial browser. And we talked about this a little bit already today, being able to find VPS locations, being able to create your own VPS locations in tandem with using the Wayfarer app. So how do we use that with our project to actually make a location-based experience? So we're going to go to the geospatial browser. I'll show that real quick just to show what it looks like, and then we'll go to a specific location, actually. So here, I believe it defaults there, just between San Francisco and San Jose, right by our Palo Alto office. And what this does is it's showing all the VPS locations or locations that we have data on, and you can select, walk through them. It will load a mesh. Some are higher quality than others, but you'll see that this is the mesh you can actually download in your project. So if you wanted to use, presumably this griffin is a, looks like some kind of poster maybe, and it does vary in quality. Sometimes it's very obvious, and sometimes it's kind of hard to see what the scans are. For this one, I'm not actually sure exactly where the griffin's, this picture is, but you can pull in the mesh. You can work with this storefront, these bushes, this ground, if you wanted to practice or test using a location in your Unity project. So just look at a couple here. You can also see if the location is VPS activated, where in the world using that address it is, and be able to see its lat long, its name. This blob is also important, which we will talk about in a little bit. So for the sake of this workshop, we're going to go find this location, which is right outside our Seattle office, which is, maybe you've seen it before. It's a kind of a famous one, well, famous by our testing standards because it has a lot of good data, and we use it for a lot of these workshops. So this is called a relic. Two ways to do this. If you have the link handy under resources, you can navigate directly to it. If you do not have the link handy, then we can actually just go in the geospatial browser and we can search for One Bellevue Center, which is a building near it. And that will take us all the way over here to Bellevue, Washington. And give it a second to load all of that. And then then yeah, this should put us right at the relic. So you can see here, this is the relic. This is a very high quality mesh. It's got a lot of good scans, which is why it's great for demonstrating the capability of VPS and location-based experiences. So here we have our relic. Perfect. And then we're actually going to download the mesh, and we're going to save that file as well. So going back to that relic, we're going to click download mesh. And this is another one that I have many, many versions of, but we'll save that to the folder that we're working with today. And drag it over there. So now we have our relic. I believe you can leave that zipped for now. Great. So now we've gone to geospatial browser. We found a location. We've downloaded the location's mesh, and we've saved it in a place we can find. Next, our location-based content. So we're going to bring in that location to Unity. And we're going to do that by going to our assets folder and then drag and dropping the zip file that we just pulled in. So in Unity, we have our assets folder, and we're going to go find our relic zip. And we're just going to drag and drop that in right here. And you'll wait just a second, it'll process. And then you'll see a couple files. You'll see the prefab here with the mesh on it, and you'll see a manifest. This manifest file has some of that key information we saw in the geospatial browser. It has the location name, its latitude, longitude, the mesh asset here, and then the anchor payload, which is really the key field we use to, it's a unique identifier for that location. And when you're using VPS, that's kind of the key that we use the VPS to say, hey, this is where I'm trying to localize to. So yeah, so we just found the location, we drag and dropped it, and it automatically extracted these assets here. So now we're going to select our XR origin, and that will have an AR location manager component. We'll do a few things with that. So XR origin here in our hierarchy, and that will have an AR location manager. And we're going to click this auto track checkbox. And then from there, we're also going to add an AR location. So here we are, location manager, AR location, add AR location. And then we're going to take this manifest that we extracted from our zip file, and we're going to drag and drop it right there. And that'll populate these things. And you should also see this mesh appear. Whoops, do this. So again, what we did there was select our XR origin, our AR location manager, click the auto track, add an AR location, assign the relic manifest to that AR location. And so then it should look like something like this on the XR origin, and it should look something like this. You should see a new relic object in the hierarchy as well right here. All right, so now let's place some actual digital content by this location. So in the assets folder, I'm going to search for a Yeti prefab that we actually have already. So let's go find that. So here in assets, I'm going to click the little search bar here, and I need to remind myself what this is called: custom animated Yeti. So custom animated Yeti, and you should find this Yeti asset here. So once we find that asset, we're going to drag it onto the relic game object to make it a child and change its scale to make it bigger. So grab this, drop it under our relic, and then I'm going to scale it up in the inspector to 666 just to make it nice and big. Feel free to move it around. If you want it right in the middle, nice and easy, somewhere that'll be very that's very near the relic. So then when we localize, we know we're going to be able to see it. So right now what we're doing is really authoring digital content relative to this location. And you can change its colors as well, I believe. I was going to make it a nice bright pink. Maybe, or maybe not. Maybe we'll leave it white. That's fine. We'll leave it there. Okay, great. So from there, we've actually brought in a location from the geospatial browser, curated some content for it. And now, presumably, in air quotes, everything should just work. Everything should, we should be able to localize to this relic location, and we should have Dodie the Yeti appear to say, hey, you had configured this object, this Yeti, for this location, and now we know you're at this location, so here's your content. We'll do another checkpoint stop here, and thumbs up, thumbs downs. I just want to see how we're doing here. I know we're going really fast. See a couple thumbs ups. Pretty quiet on the reactions. All right, well, in the virtue of time, we will keep going. Last but not least, we are going to test our location-based content. And we're going to do this using an AR session playback file. So we do have a playback file available on our GitHub. And that can also be found on the resources that were provided for this workshop. And I have the link right here as well. So I'm just going to navigate directly to the link, but it looks like it's the link that looks like this. We have Lightship, Niantic Lightship, ARDK samples, releases, downloads. It was brought in our 3.3 version, and there is a relic playback dataset TGZ file. And by navigating to that, we will download that file. I'm going to put it right along with all of my other files that we've been saving for this project. So now we have a playback file. Okay, so now that we have a playback file, we unzipped the file as well. Almost forgot about that. So we brought in the TGZ, we'll unzip it, and it should look something like this with a whole bunch of frames. So now back in Unity, we'll go to our Lightship settings and Lightship dropdown settings. And you can actually tick this playback section and make sure it's selected as editor and enabled is checked. And then you can set the dataset path to where we just unzipped our dataset. Mine's actually already set, so I will just leave it there. But this will be the folder with all of the frames in it that we just extracted from our TGZ download. And then lastly, select loop infinitely and make sure that run manually is not checked. All right, so now if we did everything right, we can press play in Unity and we can localize the VPS and trigger our content to appear. So live demos always work. So let's also, if you see here, I've set up my simulator such that it looks like an iPhone. That's a nice setting you can do in Unity just to make your testing look a little more realistic as opposed to having the resolution dimensions a little bit different. So let's see what happens. So now this is the playback file that's playing. Essentially, this is recording that was taken previously, but all of our AR and all of our depth and all of our features are actually running while the playback file is being played through. And then we have our Yeti there that appears. So what's actually happening here is as this playback file is playing, it's talking to VPS and saying, hey, we think we're at this relic location. Here is what the camera feed is giving you. Do you recognize this location? And because the Dodie appeared and it says anchor tracked, essentially that in this sample scene, that's our feedback saying, you're right, we do recognize this location. We've successfully localized you. Here's your content. So this was successfully localizing. And from there, I think we have a little bit of time. So what we did today in this very fast walkthrough of using VPS, we used the geospatial browser to find our AR locations and get the mesh of that location, pull it into our Unity project. We remotely authored some digital content to our AR location, the relic. We were able to download and pull in and use the ARDK sample scenes, notably the remote authoring scene, which allows us to kind of kickstart our testing and kickstart our application development. And then we were able to use an AR session playback recording to test our AR features, to actually test VPS in the Unity editor without needing to go physically to that location, drive, walk, etc. So there's the crash course. We do have a lot of resources worth mentioning before we go to Q&A. Lightship.dev is where you can learn all about the product. You can sign up for an account. You can manage your projects, your API keys. We have our documentation portal, which has detailed documentation, new how-to guides, our API reference, release notes, feature pages, everything to know about our features and our development kit you can find there. Our GitHub, so you can get started quickly, just as we did today, by downloading a sample project or downloading the actual ARDK package itself. And then our community developer Discord, which I know some of you here are already in, which is great. But this is the Discord where a lot of our developers hang out, talk about what you're working on, collaborate on issues, or thought starters, or hey, I'm trying to accomplish this. Has anybody done that before? That sort of thing. So please feel free to join that. I believe these should all be linked in the resources that are provided before the session. If not, try a quick Google search, or we will follow up after this session with where to find some of these links. And apologies for me featuring my dog here, who's being a little ornery. And from there, I think we have about 8 minutes for Q&A. So thank you for bearing with me on a short timeline here. Hopefully you got something out of that session, and hopefully I'm able to use this recording, if nothing else, to understand how to get started with VPS quickly. So with that, we will go to Q&A. I'll stop sharing. And Ricky, I believe you might have the keys to the Q&A area, or we can leverage the chat as well. So I'll kind of turn it to you for there.
Yeah, it looks like the only ones on here are from Hugo. I don't know how I can share them because it's like a little tab for me, but it looks like he dropped them into the main chat too, if you just want to pull from there.
Yeah, let's do it. And I see, thank you, Maverick, and some of our support folks for answering questions as we go, which is super helpful. Let's see. Questions about reactivating locations. So some of these locations have not great scans probably provided by some game players. If you've done multiple good quality scans of a location and asked to reactivate it, but it merges your scans with the previous mangled scans, is there a workaround for that? So the way that scans are intended to work is every time you provide a new scan, it's included into what is the one available mesh for you to download. So you'll notice on the geospatial browser we had, it said download mesh, and it was just one option. That mesh is going to be a fused version of all of the scans that have been taken for that location. So in theory, it should be the best quality scan we can provide. Even in some of the examples we walked through, you'll notice that, to your point, scans can vary in quality both by did they capture the right thing? I didn't necessarily see that griffin poster in the mesh we saw, but it was definitely high quality mesh because we had the entire outline of a building front. We had some bushes and in the ground as well. So the more scans, the more high quality scans that are provided, the better that mesh gets. But it will be fused with all the meshes provided generally. And thank you, Maverick. I guess I should read those first as the responses from our support team first. I mean, mostly repeated what Maverick answered.
If I can just clarify, because I'm
Sure.
not sure. So, you're combining, let's say, there was 20 meh scans before,
Yep.
and I did 10 great scans, and it's combining into 30 scans of varying quality, right?
Yep.
Altogether. Is there a way for me to access just the good scans that were done afterwards? That's, I guess, what I'm trying to get at. Like, can I tell, hey, Nick, ignore those bad ones because I've just got you some good ones?
Yeah, unfortunately not. And the asterisk there, I guess, is especially for, so I guess we do two parts. We do have automation to say if it was high quality in terms of high fidelity. Did you walk around a thing enough? Was the camera all over like this? How was the lighting? Things like that. But we don't have automation to understand, hey, you were trying to focus on that Griffin poster, but you captured everything except for that Griffin poster. We don't have automation to know what it is you're trying to focus on, like what specific landmark. So I guess the short answer is, to answer your question, is not really. In theory, those good scans should prevail because we're going to look at the data from those scans and say, okay, these good scans are giving us way more, so that's going to kind of override the low quality ones, but not so much so to your point of the bad ones go away. We're just kind of trying to overwrite them over time.
Okay.
I think it could be worth like a support ticket. We could look at it manually until we have a scalable way to doing that. So let's say you have a location near you that you're using for an experience, and you're like, hey, I'm giving great scans, but these other bad ones are really hindering my ability to do it. I would say feel free to make a ticket right into us so we can take a look, because we can manually, click through the 30 scans and say, oh yeah, the first 10 were very poor. The back 20, who are presumably from you, look great. So like, let's just remove those from the equation. But right now it's not automated.
Awesome. Thank you.
Yeah. With just a few minutes left, it looks like most questions do have at least some answers in the chat. Since they have answers, I'll see if anybody wants to ask any questions live. Otherwise, I'm happy to talk a little more about some of the questions that were asked. Oh, actually, there is a QA here from Dylan. For loading in multiple locations, do you recommend creating separate scenes or loading them in dynamically through the AR Location Manager? Is loading them in the AR Location Manager recommended? Yeah, I would say you can. I wouldn't recommend multiple scenes for it, unless they're drastically different use cases. So if you would use multiple scenes for this functionality without the workaround of VPS, then do multiple scenes. Otherwise, there are a couple ways you can manage the multiple locations. Like you said, adding the location manager is a good way, but actually obtaining the locations, we have a VPS coverage API, which I didn't mention today, but essentially it allows you to query where the user is, and say, hey, give me VPS locations nearby. And then from that, you could get the that key, that default anchor payload, and say, okay, we're at the fountain, but now I want the user to go to the statue. So let's select that and load that location in instead. And that can be done, and then you can toss that into the AR Location Manager to say, like, this is now what we're focused on. Let's try to localize to this. I'd recommend that over multiple scenes, unless like your game mechanic or application flow makes sense to have multiple scenes. And Pablo, I see you joined as well. Want to give you a chance to make sure we're on time here. We just moved on to some Q&A.
Yeah, great. Yeah, we're approaching 12 o'clock, so maybe if you have time for one more question there, that'd be great. I just don't know where you all are in that Q&A list.
Yeah, I think all the questions I believe have answers thanks to our support team here. Yeah, so if anybody has any questions live, I'm happy to take one more. Otherwise, yeah, otherwise, great. Here's a question. Oh, wait. Oh, no, sorry, just a response. Oh, yeah, question 2. When I download a mesh, multiple zip files, different mesh scans parts, when bringing it to 3D modeling program uses a reference, should I use them all? Is it okay to use one versus the other? Let's see. I don't have as much experience in modeling programs themselves. I would say using one is probably the best way to go. Just using one high quality one. I think trying to use all of the parts together will kind of be redundant in that effort of fusing to one good one. However, if you're talking about things like textures and depth data, then you will want those, but I don't think that's what you're referring to. One more real quick, and then we'll Pablo, we can adjourn here. Put one in Q&A. Let's say you want a creative experience that is available for all VPS waste spots. What I think I picked up before is possible to get the mesh of the specific VPS at runtime. At runtime, current as of exactly today, it is not, but in 3.6, which is coming in a month, it will be. So we have an API coming that allows you to actually pull down the mesh. Right now, you can only do that through the geospatial browser, and that has to be done ahead of time. So wait about 4 or 5 weeks, and we will be able to pull that down dynamically via an API.
Alrighty, cool. Thank you so much for answering all those questions, Braxton. Ricky, for holding down the fort on this side. Thank you. Anu and your team, thank you so much for joining and answering a lot of the questions with the developer support engineers. We will hope to see you all next week at the Kinfolk event. You can RSVP for that at nianticARevents.8thwall.com. And then the following week, we will have a coffee chat. This is a great opportunity to do a deeper dive into code. We had a question in the 8th Wall session, is like, how can I get more support for the actual code that I'm building? The coffee chat is a great opportunity for that. Developer support engineers will be standing by, and we can also break out into different rooms depending on if someone has a longer question. So I hope to see you all at those 2 upcoming events. And then further down the road in the challenge month, we will also host one-to-one sessions where you all will be able to talk independently with any sort of support engineers that are available. So with that, thank you so much for joining another of our webinar events, and we will see you all next week.